Hello everyone, this is the demonstration video of the cloth dynamics node that is available in the upcoming Blender 5.2. So this node is really amazing. It provides a lot of functionality and to do the cloth physics directly in the geometry nodes. So in this video I'll show you how to use that node and its settings and how to add the custom forces and also the forces from my extra node preset. So let's get started. So first we're going to add the plane and then we're going to add the geometry nodes. And let me delete that. We're going to use the procedural geometry. So we're going to add the grid. And let me go to the wireframe and also increase this vector so that we can see the wires, and we're going to increase this around 50 by 50. So we have a lot of vertices for the vector. So we have this. So next we're going to add the cloth dynamic node. So this node is based on the new node that is the XPBD solver. So with this new solver, we can do the physics simulation for the cloth, for the particles, and also for the hair. So based on that, so we have this cloth dynamic node. So next we're going to add that here. And if we run this, see this cloth is falling under the gravity. So let me first explain these settings. So first you have the pin. So here you can define this pin group to pin the cloth. So this is a dynamic setting. So let me add the random node. So we can change that to Boolean, plug that here, decrease this number to this. See now this cloth pinned from these points. Because it is dynamic, you can also change the settings during the simulation, or you can also even invert that. So we have this, then you have the stretchiness and bendiness. So let me go to the first frame, and if we increase this, so we have something like this. Now it is more like a rubber sheet. Okay, so you can play with these settings. After that, you have the solver settings. You can define the number of sub steps and constraint steps. If we increase the number of sub steps, we are basically improving the cloth simulations or cloth dynamics. And if you increase constraint steps, we are improving the calculations or the dynamics that is based on the constraints. Like in this case, we have the edge constraint and other inbuilt constraints for the cloth. Then you have the structure. So here you can define the like mass per vertex, friction, and the collision radius. So this is the radius from the external object, okay, for the collision. Then you have the damping, or you can say that is kind of air drag for the cloth. Then you have the gravity, and after that we have really important feature that is tearing. So we can tear this cloth based on these parameters. Like we can define the threshold, or we can define the custom group, or we can also tear that based on the Voronoi. So let me enable that, change this to Voronoi, and if we run this, let me decrease the threshold to maybe 1025. See, and then we have the effectors. So basically here we can define different effectors like collision effectors, forces, and other custom effectors. So for the collision, so let me delete this, go to the first frame. So let's we add UV sphere, scale that down, and next we need to move that into a collection. So let's call this collider. So now we have this geometry in the collider collection, and if we select that here and run the simulation, see, it is not colliding with the cloth because this object is not a collider. We have only put that into collection, but we need to convert this into a collider. So it is a similar step as we do that for the physics, like we can convert that into collision or like a rigid body static or active like that. So we have this sphere, then we can search for the collider group node, add that here. Now this geometry or this object is a collider. Now if we run the simulation, see it is colliding with the cloth, or we can move that, we can scale that. So this collider also works when you deform that or animate that. Okay, then you have different setting like a boundary option. Okay, and you can also enable this edge contacts. If you want a really precise collision, then you can enable that. Then you have like a margin, friction, and softiness. Okay, And another important thing is that this filter. So if I type here, let's say A, if we run this, see this cloth is not colliding with this collider because this collider has filter A. It is only going to collide with the cloth that has that tag. So if I type this tag here, cloth tag, and run the simulation, see it is colliding with this collider. So this is really a nice and advanced feature. So now we can define that which collider is going to collide with the cloth. So this is based on the collection, and but you can also define the factor or the collider using this option. So let me go here and delete this option, and let me pin that and bring that geometry here, this sphere. So to convert this geometry into a collider, we have the node that is collider that we have added earlier. Plug that into this. Now we're going to add this to this effector. So now if we run this, see this sphere is colliding. So here in the effector, you can also add the forces and other custom effectors. Okay. So let's bring the custom force node. Okay. So if we add that here, and let me disable the gravity. If I add the force along the x-axis, see this cloth is moving along the x-axis based on this force. But now we have these two effectors. So how to add that here? So we're going to add the combine bundle node. So we can combine that, and then we can plug that into this. So now if I move this sphere along the x-axis, see this cloth is going to collide with this sphere. See? And you may have noticed that the only downside of this node is that it don't have yet the self collision for the cloth. But most of the other features are available, so we can play with those features to get a nice result. So this is how you can combine those effectors like collider, forces, and other effectors. Then you can input that here. Okay. So let me delete that. In this case, we only need this custom force. So in the custom force node, you have two options. You can define the force based on the field, or you can define the force based on the closure. Closure is like a more advanced option to create a really complex force. So the easy method is to define the force based on the field. Then you can define the selection where it's going to affect the geometry. Then you have this force input. So here you can input your force. And then you have really two important settings, that is the geometry space and the force space. So the geometry space is where this field is going to be evaluated for this simulation geometry. Then you have the force space, and this define the space for the output force vector. Okay, the force we're going to input here, so we need to define that in which space they are. Okay, so in our case, we're going to keep that in the world space. Geometry space is also going to be the world space, and the force space is also going to be the world space. In the filter, similar to the collider, you can also define those filters to affect the cloth. Okay, so let's add the noise texture, disable that. Then we can add the V scale node, and then you can plug that here. If you run this, see this cloth is deforming based on this noise force or the turbulence force. So basically you need to input any vector field to define the force here. Okay. So now we're going to use the forces from the extra nodes. If you go to the force category, so you have this lot of forces. So first we're going to use this vertex force. So you can plug that here. So here we need to add the object to define the axis. So let's add the empty object, this single arrow. We can select that here. Then we can rotate that about the y-axis, something like that. Now if we run the simulation, see it is forming this vortex of this cloth. Okay, so here it has different settings. The important setting is this fall off. So we can define the fall off for the strength. So let's limit that something like this 0.4. And now if we run that, it's going to mostly affect this part that is near to this empty based on this follow. So next I'll show you how to combine different forces. Before that, we're going to add the option for the tiering. So let's add the store named attribute node, change that to Boolean, and let's type here tier. Then we're going to add the index node, and after that we're going to add the module node, integer module node. Then we're going to add the equal node. So when this node output is 0, we're going to make that true. So we have something like this. We're going to tier this cloth where we have this non-zero value or true value. So let me increase the y-axis count. So we have more strips. Then we can plug that here. So now we have this attribute, and that we're going to add that here. So first enable this option, then use custom, and here we're going to add that attribute tier. So now if we run this, see, as this force is increasing, this cloth is steering based on the defined pattern. The threshold is defined by this value. So basically, when we set this to a higher value or greater than value, let's say 2, it's going to only tear the cloth when the edge length is greater than 2 times of the original value. But in this case, the force is not that strong, so the cloth is not tearing. But if we set this to a really close to 1, something like that, then the force can increase the length greater than this factor, then the cloth will tear. See? And if we set this to a small value, let's say around 0.25, the cloth will tear from the start. Okay. So in this case, we're going to use this threshold. Let me also decrease the all off. So we have something like that. And then we're going to add a new force, that is the turbulence force. So we're going to add the turbulence force. Okay, add that here. So now if we run the simulation, we have this turbulence. Let me increase the scale. Okay, right now it is affecting the whole cloth, but I only want to affect the cloth that is based on the fall off. So we have this, so we can directly plug that into the strength. So this fall off is from 0 to 1, or you can say this strength will vary from 0 to 1. However, if you want to control the strength, you can also add a multiply node here. So here you can define the strength of this node based on this fall off. So now if you run that, see, now the turbulence is only affecting this region, not the outer region. Let's also shade smooth this. Then you can also add another node that is available in the extra node, that is the store random attribute. Because we have this multiple mesh islands, so we can use this option, mesh island option, to store a random value per island. So if I add the name attribute node, we can see them. See, we have this random values per island, so we can use that to add a different material or the color variation for these strips. So next, you can also add the solidify to this, to add a thickness to this, maybe something like that. And then you can also add the bevel to this, to bevel this around 0.0025, make this around 3. Yeah. And then you can render that with the cool lighting to get a nice effect. So next I'll show you how to add other forces like the curve force and other effector forces. So let's add another one, that is the curve force node. Plug that here. Go to the first frame. Let me hide this empty. Then we're going to add the curve. Rotate this. Bring that here. So we have something like that. We can select that. for this force. And now if you run this, see these strips are moving along this curve. Let me tweak these parameters. So this is the fall off. So let's first increase the tangent strength, decrease the radial strength, and enable the fall off for both the strengths, and decrease this around 0.25. So now we have this kind of effect. And this will look really cool if we have the self collision for the cloth, but for this version we don't have that. So basically this is how you can use this curve force node. This is also really cool. Another one is the surface force node. So let me add that surface force node. So we can use any surface to create this force. So let's add a cube, select that here. So now if we run that, see this is attracted to this. So let's make some nice effect based on that. So first we're going to pin these strips from the side. So let's add the fall off node. So we're going to use the mesh edge fall off node. So we have this, enable this option, decrease the width. So now we have only the outer boundary. Then we can duplicate this node, plug this into this, and let's call this pin. And here we can add that pin. See, we have this. Let me also add the fall off to the strength. Enable that and decrease this something like that, 0.075. So now let me move this to y-axis. We have this. Now we can move that. So this kind of interactive effect, let me move that above. So if I move this, go to the first frame, I think the fall off is really small. Yeah, something like that. Go to the this side and let's run the simulation. You can create this kind of interactive strips or effects with this. So this is how you can add different forces or custom forces to create really nice effect with this cloth dynamics. So I hope you learned something from this video. You can get the project files from my Patreon page. So thank you for watching. See you in the next video. Happy noding. Bye.